Hi, welcome to my video. Hope you all are well. Thank you for joining my presentation. Before I start, let me introduce myself. I am Lorista as a student from Nutrition Department of Health Polytechnic Semarang. In this session, I would like to discuss about cow's milk pasteurization technology in improving milk quality. First of all, it is important for us to know what milk is. Cow's milk is one of the sources of animal protein that has many roles in human life because of the many complete and complex nutritional components contained in it. Milk in general has a composition of water 7.2%, fat 3.7%, protein 3.5%, lactose 4.9%, and minerals 0.07%. The composition of milk varies depending on many factors such as species, genetic variation within species, health, environment, management, lactation stage, and age. In one glass of cow's milk contains 122 calories, 8 grams of protein, 5 grams of fat, and 12 grams of carbohydrates. The high nutritional value of milk makes milk a suitable medium for microorganisms to grow and develop. So milk has a short shelf life if not handled properly. Therefore, pasteurization is chosen in the processing of fresh milk so that it remains durable for a certain period of time. What is milk pasteurization? Pasteurized milk based on SNI 013951-1995 is milk that has undergone a heating process at a minimum temperature of 72 degrees Celsius for 15 seconds, or at a temperature of 63 until 66 degrees Celsius for 30 minutes, which is immediately cooled to a temperature of 10 degrees Celsius. Then, after cooling, the milk is treated aseptically and stored at a maximum temperature of 4.4 degrees Celsius. Processing with pasteurization technology is carried out to avoid contamination with microorganisms such as Staphylococcus aureus and Escherichia coli. Cow's milk contaminated by Staphylococcus aureus does not cause physical changes in milk, so its existence is not realized by consumers. Meanwhile, the presence of Escherichia coli in a food indicates that contamination has occurred due to poor sanitation during product preparation and processing, so that Escherichia coli contamination is used as an indicator of sanitation in food, including cow's milk. That need to be discussed is the existence of pasteurization technology raises several theories which say that some heating effects affects the quality and properties of cow's milk. Heating cow's milk causes several effects, including the degradation of lactose into organic acids, protein denaturation, destruction of vitamins and enzymes, hydrolysis of proteins and lipids, and calcium or phosphorus balance disorders. Based on research by Pastana et al. 2015, raw cow's milk and pasteurized cow's milk have very similar fatty acid profiles. Treatment during pasteurization in milk slightly affects the fatty acid profile. They also evaluated the composition and profile of raw materials and fatty acids of pasteurized milk in mini dairies and found no significant difference from the effects of pasteurization in raw milk. Another study of Hersala et al. 2005 evaluated the effect of the low temperature pasteurization process on the lipid profile of milk, found no significant difference in stochastic frontier approach or SFA, which means the pasteurization process of cow's milk does not substantially affects the fatty acid profile of milk. The main aims of heat treatment in pasteurization are: first, to reduce the microbial population, both pathogenic and spoilage; second, to inactive enzymes and to minimize chemical reaction and physical changes. To further understand this topic, first we will discuss about determination, proximate, and physicochemical composition and microbiological parameters, which includes several steps such as: first, determining the level of moisture, amount of protein, total fat, lactose, total solids, free fat dry extract, urea, calcium, and phosphorus using NocoScan. Second, measuring the pH of the sample using a Mettler Toledo pH meter and counting the number of somatic cells and the total number of bacteria were analyzed by NocoScan. From these steps, it is clear that the major nutrients of milk, protein, and lactose were not influenced by pasteurization. Second, calcium and phosphorus concentrations in the samples did not show significant differences. At pH 6.7, only about 30% of the denatured whey proteins are associated with the casein micelle surface. The second one is about fat extraction and fatty acid profile using Latimer's method 2012, which states that first, raw and pasteurized milks had very similar fatty acid profiles. Second, low temperature pasteurization process on the lipid profile of milk did not find significant difference in SFA, and 2% of total fatty acids did not present difference after pasteurization. In In conclusion, pasteurized milk at high temperatures still retains the protein and lactose contained in it. Pasteurization only slightly changes the composition of the milk, lowering total fat and total solids. Fat and total solids. With pasteurization, cow's milk will have a longer shelf life. Okay, that's bring us to the end of the presentation. I would like to close this session by saying thank you for your attention and hope it will be useful. See you later.